This is question 3 from exercise 1.9 in New Concise Project Maths 3b. We have to show that the line L and the curve C do not intersect. Our line L in this case is y equals x minus 3, and our curve C is y equals x squared plus 3x plus 2. And since they are both set equal to y, we're going to set them equal to each other to start with to try and get this answered. So we're going to go x squared plus 3x plus 2 is equal to x minus 3. So we're just setting both of the y values equal to each other. And now, because what we've got is a quadratic, we're going to move everything over to the left. So we're going to get x squared plus 3x minus x plus 2 plus 3 is equal to 0. And we tidy that up, we're going to get x squared plus 2x plus 5 is equal to 0. Now this is not a quadratic equation that we can factorize. There aren't any factors of 5 that will sum to 2. So we're going to have to look to the quadratic formula, also known as the minus b formula sometimes. So that's x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. But since we're only concerned with whether the lines and the curve intersect or not, we need to find out if this equation is going to have real or imaginary roots. And the part of this formula that's going to tell us that is the bit underneath the square root, known as the discriminant. If we get a negative number underneath our square root, then what that would mean is that this quadratic equation that we formed has imaginary roots. And that would prove that the line and the curve don't intersect. So rather than do the entire formula out, what we're going to do is we're going to just take the bit under the square root, the b squared minus 4ac, and work that out. So from this, our a is equal to 1, our b is equal to 2, and our c is equal to 5. And if we put that into this here, we're going to get 2 squared minus 4 times 1 times 5. Now 2 squared is 4, and 4 times 1 times 5 is going to make minus 20. So we're going to get minus 16. And because we got minus 16 from this, that proves that this line and this curve do not intersect. Now alternatively, if you wanted, you could work out the entire formula and get the two roots for the equation. So if you were to do that, you'd end up with x is equal to, and we'd have minus 2 plus or minus, now we already worked out the bit under the square root, it's going to be minus 16, so it's going to be root minus 16. And that's all going to be over 2a, so that's 2 times 1. So we would get x equals minus 2 plus or minus, and then the root of minus 16 is 4i, and that's all going to be over 2, which means that the roots of this equation are going to be x equals minus 1 plus or minus 2i. And the fact that the roots have an I in it means that they're imaginary. And because we've got a complex number, it's because we have an imaginary number, it means that the line and the curve don't intersect. So either method to the left or right of the line that I've drawn here will suffice to confirm this. It just depends on which you remember to do on the day. And that is that.